section is on dot products and orthogonality, and in this section we're going to talk about all of these geometric concepts that we've learned before in the past in 2 dimensions, but now we're going to generalize them and talk about what they look like in multiple dimensions, so in Rn. Alright, so I'll put that note here. Geometric concepts of length, distance, and perpendicularity are well known in R2. So you know how to find length, distance, and if 2 things are perpendicular, 2 lines are perpendicular in 2 dimensions. Very easy to do. You can go back to pre-calculus to remember. But in this section, we will define them for Rn. All right, so let's just start with an example. So let's say we have a vector in R3, and that vector is 1, 2, 3. And we also have another vector in R3. We'll call it V, -1, 0, 2. So we have 2 vectors, U and V. So the first thing that I want to talk about is a dot product. So you may have learned this before. So U dot V. And so this is different than just a regular multiplication dot. It's like a filled in bold circle. This is known as the inner product or dot product of U and V. So as you know, we don't really have a way to multiply 2 vectors together. So we use the inner product or the dot product, and here's how it's defined. It's defined by multiplying, and sorry, I think I misspoke. Multiplying 2 vectors of the same length is not easy to do. All right, so what we will do is multiply the transpose of U by V. That way the dimensions match up and it's actually possible to do the multiplication. So U dot V is U transpose times V. So how do we find the transpose? Columns become rows, so this becomes a row vector multiplied by our column vector. And now this is something we can actually multiply, right? Across and down. So we'll have our -1 plus 0 plus 6. So the dot product of these 2 vectors is 5. All right, let's look at another example. All right, so let's say we have the vector V, and it's in R2, -1, 2. Since it's in R2, I'm going to go ahead and draw this vector so we can get a visual representation of what's happening and what we're going to be doing with it. Okay, this should be enough. All right, so the vector -1, 2 looks like this. This is our vector V. What if we wanted to find the length of our vector V? So from the origin to the tip of our arrow, how would we do that? Well, this is just a line, so we know how to find the distance between 2 points on a line, so we know the length of this line. We can use Euclidean distance. So the Euclidean distance between the origin, so that's, well, let's do the point -1, 2, and the origin 0, 0. You guys know how to do this. Square root distance between the x value squared plus the distance between the y value squared. It's the square root of 5. So that is the length of this vector v. Also, notice this is actually the same as the square root of v dot product with itself. So if you take the dot product of v with itself, you're going to get 5. So square root of 5. Maybe I should work it all out so you guys can see it. All right, so this is v dot v, which the way we do it is we do the transpose of v dot product with v. So v transpose is a row vector, -1, 2, times the column vector, -1, 2. Multiply that together and get 5. So this is also the square root of 5. And so this is actually what we're going to use to determine the length of any vector in any dimension, not just in R2. So let's get that definition. All right, so the length, also known as the norm, so you may have heard norm before, it's the same thing as length, of a vector v is the non-negative scalar and so what we're going to use to denote the length or the norm is the double bar. So it almost looks like 2 absolute values. Defined by, so the length or norm of a vector is the non-negative scalar. We usually say the norm of v is defined in this way. So the norm of v is the same as the square root of v dot product with itself. Right, and so depending on the length of the vector, so let's say this is a vector in Rn, the dot product would look like this. The first component squared plus the second component squared all the way to the nth component squared. Because that's what happens when you do a dot product of a vector with itself. All right. And also, something to note is that if you square the norm, you just get the dot product. All right, so in the next video, we're going to talk about what a unit vector is.